In this video, we're going to demonstrate how to take an existing IDF file and use Modelkit with it and parameterize it and create different cases of the IDF file that you already have. So if we go to the Modelkit Catalyst folder and the examples folder, we've been working with this simple project. If we just copy that whole folder and paste it, and I'll just call this existing project. So if we go into the templates, we don't need the geometry or location. So in the previous videos, we've been building up this root.pxt file. And this root file is pulling from all these different templates that come with the Modelkit installation. But if we want to use an existing IDF file and we only want to change like one field or one parameter, we can actually just paste in our IDF file as the root file. So for this example, we'll use the ASHRAE 90.1 2016 Office Small prototype in Denver. And if we just copy this entire model and paste it below our interface in the root file, I'll just delete all these comments up top. And now let's say we just want to vary the thickness of one of the constructions. So we can make a parameter name called thickness. And now let's just look at the materials. So let's just say we want to change the thickness of this material. We would put our embedded Ruby syntax with that thickness parameter that we just created. And now we can set our default value for thickness to its current value. And that's all we need to do if we just want to vary that one field. I'll show you after this a way to break down this IDF file into pieces and then parameterize different pieces of the IDF file, which is helpful if you're doing more complex parameterizations. But if you're just trying to parameterize one variable, the easiest way is just to use your IDF file as the root file and then add this interface at the top and specify your parameters somewhere within the IDF file. So the other way to do this is to break down the IDF file into pieces. And the way I do that is, what I normally do is I create a folder called pieces, and then I create different sections of an IDF file. So if you go to the DOE website, you can download these commercial prototype building models, and there's a number of different building types. What I'll be using for this demonstration is the small office prototype in ASHRAE 90.1 2016 in Denver. So and I already updated this to version 8.9. So if you download these models, they'll be in version 8.0, well, at least right now they are. So you'll have to update the IDF file to version 8.9. That's just the version that we've been using in the previous examples, but it really doesn't matter which version you use, you just have to be consistent in which engine you're telling Modelkit to use. But just for simplicity, we'll use version 8.9 like we did last time. So once you have this file updated to 8.9, this is just a suggestion, but I like to break up the IDF file by class. So, and the easiest way to do that is if you sort the IDF file. And the easiest way to sort the IDF file is if you edit it within IDF editor, duplicate, delete, save as. So I'll call this file the same name, but just with sorted at the end. If you're not sure if your IDF editor is configured to sort the IDF files, if you go to Save Options, you can switch to Sorted. And you can see all of the objects are now sorted by class. It just makes breaking up the IDF file a little bit easier. So there's all these comments at the top of the IDF file. I'm just going to delete them for now. And if we just search by this header object here, we can kind of scroll through each of the object classes. So starting at the top, I usually put all of this just general simulation parameters up until like the location objects. I'll cut all of this out and create a new file and paste that in there. And I'll save this as a new file called 01general.idf. So this is just a piece of an IDF file. Well, it's an IDF file, it's just not a complete model. And then I'll just split this to the right and keep going down, searching by that object class header until this is all like the site location and location specific objects, and I'll just copy or cut all of that and paste it, and then save this as DDY for design day. And then I'll keep going down. These are all the schedules. You probably get the idea of what I'm doing here, but so you can see how we broke down this one large IDF file into 10 smaller IDF files. And now if we want to manipulate just the constructions, for example, we can just change that one file and leave all the other files the same. So let's say that that's the task that you have to do, is you have this model and you want to test out some different constructions, for example. So you want to parameterize some of the variables in the constructions. What I usually do is copy the IDF file and make a new version of it, and that way I always retain those original IDF file objects. And also I change, I keep it 04 constructions, and then I just change the extension to PXT, which is the Modelkit template extension. You can change it to whatever extension you want, but what's nice about PXT is that if you're using Atom text editor and you have the language EnergyPlus package installed, which is a package that recognizes IDF files, it'll also recognize the .pxt extension as an IDF file, so you'll get all the nice formatting. But let's first delete all these comments out off the top. And then just like any of the other template files, if we open up that simple project, which again is in Documents, Modelkit Catalyst, Templates, Net Zero Templates, Templates, and any of these really, it'll have this initialize, or sometimes it says interface at the top. If we just copy that just to get that syntax, and then we'll delete all these parameters except for one. So let's just say that we want to vary the thickness of this material, which doesn't really make sense because it's a 6-inch wood stud, but let's just say we want to change that thickness. So first let's define the parameter on here. So we'll call this thickness, and we'll assign it a default value of what it is now, which is 0.15. And then instead of the 0.15, we just put that embedded Ruby syntax. And now we can change this parameter to any value that we want. So if we save that, now in our root file, it's a pretty simple root file. We'll just delete all of this stuff. Just delete all that. And now we're inserting templates from our pieces folder. 01 general.idf, 02 DDY, 03 schedules, 04 constructions, and this one is constructions PXT, and we're feeding it its variable called thickness. And we can either assign it a thickness in our root file here, like 0.1, or we can make our own local parameter. We'll call it something different, call it width, and we can again assign a default local value, which we'll just make the same as the template value, 0.15. And now we're feeding that local variable called width for thickness in our constructions template. We'll insert the rest of the pieces, 05, and that's what our root file looks like with all the pieces. Just insert piece, And then the only one difference is instead of 04 constructions.idf, we're inserting this constructions.pxt that has a variable parameter called thickness, which we're feeding it our local variable called width. So let's say we want to compose this model with two different width values. So we would go to our cases folder, which is in parameters, cases, and instead of all these cases for the different climate zones, we'll just delete all of them, and we'll just make a base and proposed case file. So this one we'll call base, and we'll just leave this one blank, so it'll just use that default width value of 0.15. And then we'll make a copy of this and save it as prop. And for this, we'll feed it a width of 0.3. So this should compose two models, one using the default width parameter and one using a width parameter of 0.3. So if you remember from the last video, we composed these models using a rake file. So we'll use the same rake file, but instead of composing and simulating over this list of locations, we instead just want to compose and simulate our base case and our proposed case. So if we look at how this list locations is used, it's used in each of our tasks here. It's looping over the locations list for cases, compose, and sim. It's also used in this weather path, which is the path to the weather file that we want to use when we simulate the model. So we want to keep this list locations, but instead we'll just replace it with the name of the weather file that we want to use. And the weather file that we want to use, we want to put it in our template directory in a folder called weather. So that would be in Modelkit Catalyst, templates, net zero templates, templates, weather. And I already copied the weather file that we'll be using for this demonstration, which is Aurora Buckley Field. So we just want to copy that file name and paste it as our one location. And then I'm going to make another list called runs. And for this, I'll just put our base and prop. And now instead of generating cases using this cases task, it's not really necessary if we just want to use two case files, because we just created those two case files, base and prop, manually. But you can imagine if you wanted to simulate, for example, a list of different thicknesses, you could use this task to create those case files for you. But instead, we'll just delete it for this example. And now in our compose task, instead of location in locations, we'll change that to for run in runs. And now our PXV path, instead of case directories and then the location, it's going to be cases directory and the run. Similarly, for all of these lines, I'll just copy and run instead of location. And we're going to do the same thing for the sim task. And for the weather path, instead of the weather directory plus location.upw, since we're not looping over location and locations, what we actually want to do there is feed it the first item in this list called locations. So we can just change this to locations 0. Modelkit folder, open a command window there, and just to make sure our rake file is working, we'll do rake-T, and it lists the two rake tasks that we have. So let's rake compose. So we got this error, and it's saying that there's no such file in this directory, and you'll notice it's referencing the simple project directory. And that's because our rake file is still setting the main directory to be this simple project folder. So we would just want to change this to existing project. Now if we try to compose it, it composed our base and our prop model. Let's just compare those two models that it just created. Oh, and it still has all these models in the runs folder from our previous example. We'll just delete all of those. So now we just have our base and our prop model. And if we do a quick comparison, We see in the annotations that our base has a width of 0.15 and the prop has a width of 0.3. And in the actual model objects, we can see that change reflected in our 6-inch wood stud material. So now if we want to simulate them, we just do rake sim. And it looks like it's running. So this example was just about the most simple example you could think of taking an existing IDF file, breaking it into a bunch of pieces, and parameterizing just one number, which is the thickness of this wood material. But you can imagine a more complex scenario where we're either varying this one parameter many more times, or we're varying several of the parameters, and we can insert logic for if we had a list of zone names, and we could have, for example, different HVAC system objects or templates inserted for different zone types, and essentially just use these pieces that we've created as Modelkit templates, and or just swap them out for other templates that you've either made previously or maybe one that comes with the Modelkit installation. But that's how I normally break apart an existing IDF file and parameterize it using Modelkit.